If I wanted to find all of the possible rational roots of this function and then actually figure out which one of the possibilities were actual roots, so which ones of the possibilities are actual x-intercepts, this is what I would do. I would start off by finding all of the possible rational roots. I have P, I have Q. P is always the constant, Q is always the leading coefficient. So if I'm going to do P divided by Q, I'm going to take all the factors of P and divide it by all of the factors of Q. All of the factors of P, all of the numbers that when I multiply them, I will get -1, is simply plus or minus 1. I can only do 1 times -1 to get -1. So I did +1 and -1 to get -1. If I were trying to find all the factors of 5, I'd have plus or minus 1 and plus or minus 5. I can only do 1 times 5 to get 5, but I can do +1 times +5 to get 5, and I can do -1 times -5 to get 5. So if I were to go ahead and simplify those, which means basically separating them into their own rationals, and then simplifying, I would have plus or minus 1 over plus or minus 1. I'd have plus or minus 1 over plus or minus 5. I have to take the numerator and divide it by everything in the denominator. And this one's really quick because I only have one number in the numerator. So then finally, 1 divided by 1 is 1. So this turns into plus or minus 1 and plus or minus a fifth. Those are my only possibilities. I simplified plus or minus 1 over plus or minus 1. It turned into just plus or minus 1. And I simplified plus or minus 1 over plus or minus 5. It turned into just plus or minus 1/5. So now that I've found all of the possibilities, I need to test to figure out which ones are actual roots. So I'm going to do synthetic division. I'm going to take what I think is a possible rational root. I think -1 might be. So I'm going to take -1 and I'm going to put it in my synthetic division chart. You always bring down the first number. If you don't know about synthetic division, what you do is you take a number you think is a root and you put it in a box, and then you take all of the coefficients and you put them on the top row. Now when you're doing the coefficients, be careful because if you're missing a term, you have to put a 0 there. In this case, we're not missing a term, so we're okay. But just in case we were, I would have to put a 0 there. So if I didn't have an x squared, I would have to put a 0 in the place of the x squared. Okay, so the first step in synthetic division, you bring down the 5. Once you bring down the 5, you multiply the number that's outside. You multiply the box number by the number you put down here. So I'm going to take -1 and I'm going to multiply it by 5. -1 times 5 is -5. You write that on the second line, and then you just go ahead and you do the math. You do -11 minus 5. -11 minus 5 is -16. And then you start all over again. You're going to take the number in the box, and you're going to multiply it by the number you wrote down there. -1 times -16 is +16. You write that on the second line. You do the math. What's 7 plus 16? 7 plus 16. Excuse me, I had to yawn. Excuse me. 7 plus 16. Okay, so that's 423. All right, and then I'm going to start all over again. Negative 1 times 23 is negative 23. I'm going to do the math. I got negative 24. The last number you write down when you're doing synthetic division is your remainder. Take note, if negative 1 was a factor, if negative 1 was a root to f of x, the remainder would be 0. Since I have a remainder of negative 24, it is not a root. Now, it's still a possible root, but it's a possibility, and we just found out that it wasn't an actual root. So we'll go on to the next one that we think is a root. The next one we think is a root, I'm going to say positive 1. So I'm going to put positive 1 in my little box. I'm going to write down the coefficients, making sure I didn't have any terms that were skipped. Set up my synthetic division, bring down the first number, and get started. So I'm going to take 1, and I'm going to multiply it by 5. 1 times 5 is 5. Excuse me again. I just keep yawning. So now I have negative 11 plus 5. Negative 11 plus 5 is negative 6. Start all over again. 1 times negative 6 is negative 6. Do the math. 7 minus 6. 7 minus 6 is 1. Multiply 1 times 1. 1 times 1 is 1. Do the math. Negative 1 times 1, 0. Since I have a remainder of 0, I've found that 1 is a root. I'm excited. I'm like, okay. So if I were doing division and I had to find out what the answer was, I would say that 5x cubed minus 11x squared plus 7x minus 1 divided by x minus 1 would be 5x squared minus 6x plus 1. I would then just go and see if there's another one, if there's another root. So I would do 1/5. Yep, you guessed it, another yawn. So bring down the 5, get started. 1/5 of 5. So basically I'm taking 5 and dividing it by 5. I would get 1. Negative 11 plus 1 is negative 10. 1/5 of 10, I'm taking basically negative 10, dividing it by 5. You get negative 2. 7 minus 2 is 5. We already know that 5 divided by 5 is 1. Negative 1 divided by 1, 0. So we found that 1/5 is a root. We could do negative 1/5, but I already know that negative 1/5 is not a root. I want to quickly show you that you didn't have to start at the very beginning with the polynomial you were given. You could have continued off from the one that you ended with when you found a root. So if you remember, when we first found that 1 was a root, this was our answer right here. I could have did 1/5 here, brought down my 5, and started over again. Watch what happens. 1/5 of 5, we already know, is 1. -6 plus 1 is -5. 1/5 of -5 is -1. 1 minus 1, 0. If you continue on from a root that you've already found, you have less numbers you're going to be working with. Over here, I'm working with 1, 2, 3, 4 numbers. Right here, I'm working with 1, 2, 3 numbers. And I've gotten it down to 2 numbers. So I could do -1/5. If I did -1/5, I would just continue off of this to try to see if -1/5 works. It wouldn't. Do it on your own. You will see that you would get a remainder. So I know I'm not done though. I'm not done because I have 2 numbers left. I've found all of my roots when I only have 1 number left. So what that means is the other root might be irrational, or I could have a double root. I could have a root with a multiplicity of 2. In this case, I have a root with a multiplicity of 2. 1 is a root again. It's a double root. If I were to take 1 and do it all over again, bring down my 5. 1 times 5 is 5. -5 plus 5 is 0. So all of the roots, in this case, my answer, all of the roots, 1, 1/5, and 1 again. If I were to write it in factored form, my answer would be x minus 1 squared, since it has a multiplicity of 2, and I would have 5x minus 1. If you're wondering how I got that, what I did was I took each of the roots. In this case, I had a root that had x equals 1, and I had a root that had x equals 1/5. Those were my 2 roots. I minus 1 from both sides, and I got that x minus 1 equals 0. And if you notice, that's what I have there. I did the same thing here. I'm solving for x, but it's a fraction, so I multiply by the denominator, multiply both sides by 5. Oops. Here we go. Multiply both sides by 5 and get 5x equals 1. Subtract 1. I get 5x minus 1 equals 0. And if you notice, that's what I have written there.